This is the 2012 F equals MA contest, and this is problem number 14. So we're given a uniform cylinder of radius A, and originally it has a weight of 80 newtons. Then we have another cylinder that's symmetric, except we have an off-axis cylinder hole that's 2A over 5 away from the center. Now it only weighs 65 newtons. We're told that the axes of these two cylinders are parallel and their centers are at the same height. Now we're going to apply some force T horizontally, and we're asked to find what the magnitude of T is in order to keep our cylinder at rest. So in order to keep our cylinder at rest, there must be zero net torque on our object. So let's draw our cylinder like so. So here is our center, and here is our off-axis hole that's drilled into it. Now originally we would have had another piece of the cylinder that's the same size as this hole, and they would have consisted of the same mass, since we're given that this cylinder is uniform. They would have both had mg and some distance away, some r away, which we know to be 2a over 5. However, now that this hole has been drilled away, we only have this mg with no other mg on the other side to balance it out. And so we find that there's going to be a net torque that will make our cylinder try to rotate counterclockwise. In order to prevent this from happening, we will apply a horizontal force T, and it will point in this direction with some radius r, which we know to be equal to a, the radius of the cylinder. In order to do so, then we get that there will be a net torque turning clockwise, and so the counterclockwise torque and the clockwise torque will cancel each other out. So we have that r cross t is equal to small r, which we'll call this small r, times mg. Now, like we said before, r is just equal to a, so we have a times t. And here small r is going to be equal to 2a over 5. So we have 2a over 5. And then we have mg. Now mg is just going to equal the same amount that this section would have had if we hadn't cut it out. So namely, we take the difference in weights with what's in the hole and having a hole there. So we have 80 newtons minus 65 newtons is going to equal to mg, and 80 minus 65 is just 15 newtons. So mg is just 15 newtons. So we have that T times A is equal to 2 over 5 times A times mg, which is 15 newtons. Now we cancel out the A's on both sides, and we have that T is equal to 15 over 5 times 2. So that's 15 over 5, that's 3. 3 times 2 is 6. So we find that T is just equal to 6 newtons, and that's the horizontal force required to keep our cylinder at rest.